Good morning all. In the previous class we discussed about magnetic field intensity due to infinite length of conductor. Magnetic field intensity due to current carrying conductor of infinite length. In the previous class we discussed. Now we go for magnetic field intensity due to a circular conductor. The important thing is circular conductor, it is a loop, circular conductor loop it is. Suppose if the conductor is having length, infinite length, we discussed previously, that is infinite length, what is the magnetic field intensity H bar equal to I by 2 pi r for infinite length. For finite length, H equal to I by 2 pi r sin alpha 1 cos alpha 1 plus cos alpha 2. I by 4 pi r cos alpha 1 plus cos alpha 2 a theta. This we discussed previously. If the conductor is in this manner, if the conductor is in this length, having length L like that, then at a point P, what is the magnetic field intensity we discussed previously. Now magnetic field intensity, if the conductor, ఈ కండక్టర్ని ఇలా ట్విస్ట్ చేసామనుకోండి, ఒక టర్న్ లాగా ఫామ్ అవుతుంది కదా, అంటే లాంగ్ కండక్టర్ని ఇలా టూ ఎండ్స్ జాయిన్ చేసామంటే, ఇఫ్ యూ జాయిన్ ద టూ ఎండ్స్ దెన్ ఇట్ బికమ్స్ ఏ సర్క్యులర్ కండక్టర్. ఇట్ ఈస్ ఏ సర్క్యులర్ లూప్. ఓకే, కన్సిడర్ ఏ సర్క్యులర్ కండక్టర్ లూప్ హ్యావింగ్ రేడియస్ ఏ. ద రేడియస్ ఆఫ్ ద కండక్టర్ ఈజ్ ఏ. అజ్యూమ్ దట్. ఓకే, because we already know that whenever current is flowing through this conductor, I conductor is flowing at a distance, we are considering a small differential length. ఒక చిన్న లెంత్ తీసుకొని మళ్ళీ ఇంటిగ్రేట్ చేస్తాం అట్ ఏ పాయింట్ పి. మనం అదే చేసాము అంతకుముందు. ఇప్పుడు ఆ కండక్టరే ఒక లూప్ లాగా ఫామ్ అయింది. బికాజ్ ద కండక్టర్ బికమ్స్ ఏ లూప్ హ్యావింగ్ రేడియస్ ఆర్ ఏ. The loop of the conductor is. Let current I flows through this conductor. The current I is flowing. Assume that A is the radius of the conductor. I is the current flowing through this loop. Current flowing through this loop is, you can see now the diagram is. How to understand this? If the conductor not infinite length or finite length, we are considering a DL if it is a conductor having a current I. And a point P, for finite length, we consider a DL differential length and L is the length of the conductor. Then magnetic field intensity obtained is, this is the formula, I by 4 pi r into cos alpha 1 plus cos alpha 2 a theta. If it is infinite, alpha 1 alpha 2 becomes 0, then you will get I by 2 pi r a theta. The unit vector is a theta. If the same conductor bended into a loop having radius a, then current entering in this loop is I. I is the current flow in this loop as shown in the diagram. Okay, now we are going to find H bar at a point B. H means magnetic field intensity H bar due to a circular conductor loop. See, the conductor loop having radius A. A is the radius. It is the XYZ coordinate system, that is Cartesian coordinate system we consider. The loop is, center is O, that is origin of the loop, and the loop having radius A is the radius. The loop is, this is the loop in a XYZ coordinate system. The loop is, here we can draw easily. I can redraw that XYZ coordinate system here. This is XYZ coordinate system we consider first for a circular loop. After that, the conductor having loop, conductor in the form of the loop, it is the radius of the conductor A. A is the radius of the conductor. The radius is loop, it is the loop we consider. The loop, a point P we are assuming the a point P on z axis, x, y, z axis. It is a point P located on z axis at a distance from the origin is h. Assume that h is the height of the point, or any point h. It is the h. Assume that it is origin O and radius is A. A point P is located here. Due to this DL, a small differential length we assuming, due to this DL, what is the electric field intensity, magnetic field intensity at this point we are calculating. What is the magnetic field intensity at this point we are calculating by this, a current I is flowing through this loop. Conductor having a current I is flowing in this loop. A point P is located on z-axis. At this point, what is the magnetic field intensity we are calculating? According to Biot-Savart's law only we are calculating magnetic field intensity. Okay. Now to determine magnetic field intensity, MFI at a point P on z-axis at a distance h bar from the center of the circular loop using Biot-Savart's law we will follow. According to Biot-Savart's law, what it says, dH equal to IDL sin theta by 4 pi r square. You know that already, Biot-Savart's law. dH equal to IDL sin theta by 4 pi r square. From this diagram, assume that it is a theta. It is the theta. You can see this. Assume that it is a theta. It is the theta angle. It is O, P, and this is you can assume that some point also you can assume. The triangle will be like this. This is theta, it is a point P. Now it is origin, it is a DL. Assume that a small differential length, DL it is. According to Biot-Savart's law, we can say that dH equal to IDL sin theta by 4 pi r square. IDL sin theta by 4 pi r square. From the figure, sin theta equal to, it is the radius is A, because already the radius of the circle is, the radius of the circular loop is A, we assumed. Instead of that, from the figure, it is A by R. R, what is the R? It is R. It is the R. From the figure, sin theta equal to opposite side by hypotenuse, A by R, you will get. You will get A by R. From that, sin theta equal to A by R is the hypotenuse. We can write A square plus H square. It is a H. A square plus H square gives R. Square root of A square plus H square we written. Therefore, dH equal to, we are substituting in place of sin theta, that is A by square root of A square plus H square. Divided by 4 pi R is again A square plus H square we substituted. Okay, dH equal to ideal A by square root of A by square root of A square plus H square we substituted. Simply we are substituted in place of sin theta this one. In place of R square we can substitute, in place of R square we can substitute A square plus H square. That is according to right angle triangles. Pythagoras law it is, I think, A square plus H square you can substitute. Therefore, dH bar equal to ideal A by 4 pi A square plus H square we can write. A square plus H square power 3 by 2. Power 3 by 2 we can write. It is a square root of A square plus H square power, what we can write, square root means 1 by 2. Here also A square plus H square is there, hence we can write 3 by 2. Total MFI at point P. Total MFI ante manam integrate cheyali. If you integrate with respect to total area, perimeter of the circle or perimeter of circle is 2 pi r. Total MFI at point P is due to entire conductor. ఈ కండక్టర్ వల్ల అంత టోటల్ వల్ల వస్తుంది కదా ఇక్కడ మ్యాగ్నెటిక్ ఫీల్డ్ ఇంటెన్సిటీ. మనం ఓన్లీ స్మాల్ పోర్షన్ తీసుకున్నాం. We have to integrate over the loop. Total magnetic field intensity. MFI means magnetic field intensity. H bar equal to closed integral 2 pi r ideal A by A 4 pi into A square plus H square power 3 by 2. This we substituted here. If you integrate dH, you will get H. You know that. If you integrate dH, you will get H. Hence, we are integrating with respect to total perimeter of the circle, that is 2 pi r. Since r equal to A by A, because we assumed that r equal to A by A, where 2 pi r is the perimeter of the circle, we can substitute 2 pi A in place of r, because we assumed that r equal to a. Therefore h bar equal to I dl by 4 pi a square plus h square, we can write 2 pi a square we can write. If we are integrating, I into dl becomes 2 pi a square. 2 pi a, with respect to 2 pi a we are integrating, dl becomes 2 pi a into a is there, 2 pi a square will come. After that 4 pi, if you cancel each other, you will get what you will get, you can write here. Okay, in place of I dl we are substituting, we are integrating with respect to dl. dl we are integrating to obtain magnetic field intensity total. Instead of that 2 pi a we can write 2 pi a into a, 2 pi a square by 4 pi 2 pi, and it is a 2 times we can cancel each other, pi get cancel. Here therefore ia square by 2 a square plus s square power 3 by 2 will get. Okay. Therefore h bar equal to ia square by 2 into a square plus s square power 3 by 2 a z direction it is. Okay, where circumference of the circle is 2 pi a. Similarly, at the center, what is the magnetic field intensity we can calculate? MFI due to circular conductor loop at its center. మనం ఒక పాయింట్ పి ఇక్కడ తీసుకున్నాం, ఆ సెంటర్లో ఎంత ఉంటుంది, ఆరిజిన్ దగ్గర. సో ఒక లూప్ ఉంటే లూప్ లోపల అంటే ఇన్సైడ్ ఆఫ్ ద సర్క్యులర్ కండక్టర్, here what is the magnetic field intensity we have to calculate. Now same principle we assume, but dl is same again. Okay, now at origin what is the magnetic field intensity? Point P here previously, now the point P is here, that is a center. At the origin what is the magnetic field intensity due to a circular conductor loop? Okay, conductor loop, a carrying current is I, you can see any direction. The current, a small differential length we assume, the loop radius is a again. Consider a circular conductor loop having radius a is the radius. By using Biot-Savart's law we can find magnetic field intensity. According to Biot-Savart's law, you know that ideal sin theta by 4 pi r square, where r equal to distance between dl and point P, where r is the distance, because we assumed previously ikkada p anukunnam, ikkada distance r anukunnam. Similarly, ఇక్కడ డిస్టెన్స్ ఏమవుతుంది, ఇక్కడ నుంచి ఇక్కడికి డిస్టెన్స్, ఆరిజిన్ నుంచి పాయింట్ పీకి. ఓకే, now by using Biot-Savart's law we can write dh equal to ideal sin theta by 4 pi r square, where r is the distance between dl and point P. From the figure theta equal to 90 degrees, the theta equal to 90 degrees from the figure. What is theta? dh equal to ideal sin theta by 4 pi a square, because r is replaced with a. Here ideal sin 90 ideal by 4 pi a square. Therefore h bar equal to, how we are obtaining theta equal to 90 degrees, that is the from the figure it is, you can see the angle is 0 degrees. Now if you substitute theta equal to 90 degrees, you can get dh bar equal to ideal sin 90 by 4 pi r square. Sin 90 value is 1, hence we can write dh equal to ideal by 4 pi a square. Therefore if you integrate this with respect to total circumference 2 pi r, then h bar equal to integration of dh with respect to 2 pi r integrated over the circumference, then closed integral 2 pi r ideal by 4 pi a square we can write. H equal to ideal by 4 pi a square, 2 pi a we are substituted. In place of dl we can substitute 2 pi a, because integration of dl is 2 pi a. dl is actually L. Actually here circumference we have to integrate, hence in place of dl if you integrate it becomes 2 pi a. 4 pi a already is there. If you can cancel each other, then you will get h equal to I by 2a, ampere turns per meter. H equal to units are ampere turns per meter. Okay, that is a simple method to find magnetic field intensity at the center of the square loop, center of the circular loop. If it is a square loop, that is magnetic field intensity at the center of a square loop. Okay, square loop having square loop, if you assume the length of the sides of the square loop is L by 4, we have to assume L by 4, L by 4, L by 4. At the center of point P, what is the magnetic field intensity? How can we calculate? To determine magnetic field intensity at the center of the loop, the Bird's law can be used. We know that MFI at a point P at a distance R. Okay, a square loop will be like this, a square will be. At the center, what is the magnetic field intensity? P. At point P is located at the center. This angle becomes 45, this angle becomes 45 degrees, and L is the length. Current I is flowing through this square loop. And the loop is along z axis, xyz axis. It is z axis, it is y axis, it is x axis. It is L by 4, L by 4, and at the center means it is L by 6, L by 6 we can get. Okay, to determine magnetic field intensity at the center of the square loop, at the distance r, we know that formula. At a distance r, what is the magnetic field intensity? H equal to I by 4 pi r cos alpha 1 plus cos alpha 2. From the figure, alpha 1 and alpha 2 equal to 45 degrees. Because the point P is located at the center, this angle is 45, this angle is also 45. Okay, from the figure, you can get 45 degrees because it is a square loop. For a square, how much angle will be? Okay, square ela untundi angle. Suppose if the square is like this, the angle between this and this point will be 45. We substituted this one 45 degrees in this equation. H equal to I by 4 pi r. Sin 45 cos 45 is 1 by root 2, that is root 2 I by 4 pi r. Therefore, h bar equal to I by 2 root 2 pi r, because r equal to L by 8. Assume that L by 8 it is, or since r equal to L by 8, if you substitute, it is L by 4, it is also L by 8. Exactly half ఎంత ఉంటుంది? L by 4 ఉన్నప్పుడు ఇదంతా. This is L by 4, length divided by 4. ఇది ఎంత ఉంటుంది? హాఫ్ దాంట్లో L by 4లో అంటే L by 8 ఉంటుంది. If you substitute r equal to r means this is the point P at a distance r. R అంటే ఇక్కడ L by 8. If you substitute r equal to L by 8, what you can get? After substituting r equal to L by 8, that is I by 2 root 2 pi L by 8, you will get h bar equal to, after getting cancel each other, you can get h equal to 2 root 2 I by pi L az direction. H1 equal to H2 equal to H4 equal to, if all are equal, H1, H2, H3, H4, then total MFI, that is H bar, H1, H2, H3, H4, because all magnetic field intensities all equal, that is 2 root 2 by pi L into I az you will get. If you add all, the total MFI you will get H1 equal to H2 equal to H4. If the current is not same, then you can add H1 equal to H2 equal to, if you add again 2 root 2, 2 root 2, 2 root 2, if you add, then you will get pi root 8 root 2 into I by pi L.